And now we're about to continue with the lungs themselves.
So that takes us into the lungs. Now, one thing you're going to notice on the lungs is that the left lung is different from the right lung because it has that cardiac notch. That's where the heart rests. And so the left lung is a little bit smaller and shaped differently. It only has the upper and lower lobe instead of the upper, middle, and lower lobes. In the lung itself, those bronchi, as I said, they continue into the secondary and tertiary bronchi, and finally into the bronchioles. Now, the bronchioles are the tiny little passageways that lead to the alveoli where the actual gas exchange happens. Now, these are important in a bunch of conditions. They can become inflamed in bronchitis, but more commonly, they're inflamed in asthma. Asthma is a condition where these bronchi are frequently or constantly inflamed, which means that parasympathetic stimulation, which normally constricts the airways, can cause overconstriction. So you have a combination of constant inflammation, overstimulation by the parasympathetic nervous system that constricts it enough that the air you've breathed in can't get out. And this is where people cough or have an asthmatic attack in response to this. This is why asthma frequently gets worse when people have severe allergies or a cold, or especially bronchitis. People with asthma are very prone to bronchitis because it's this inflammation that really causes the problem here. Alveoli are just a series of little tiny air sacs where the actual gas exchange happens. Around these alveoli there are capillary beds, and the blood around the capillary beds passes very, very close to these gas-filled alveoli. There's only a very thin membranous wall between the blood and the alveoli. And so the blood is just across this membrane, and the gases are exchanged between the blood and the alveoli, and then between the plasma and the red blood cells. So the red blood cells give up the CO2 to the plasma, which then goes into the alveolus and is released in the air. The alveolus has a pocket full of air that provides oxygen to the plasma, which then goes into the red blood cells and attaches to hemoglobin. In the alveoli, there are also macrophages, which, just like all of the macrophages in your system, they're wandering around eating intruders, looking for viruses and dust particles and anything else you might have inhaled. There's also surfactant and surfactant secreting cells. This helps keep the alveoli open. The alveoli need to be constantly inflated. If they start to collapse, that's where you get a collapsed lung. So even when you breathe out, there's still some amount of air in those alveoli. And the surfactant just decreases the surface tension so that they don't try and close, so that they don't get sucked closed by surface tension when you breathe out.
Now, for all of this to work, the blood supply has to get to those alveoli. So this is where the pulmonary blood supply from the heart comes in. So remember that half your heart is devoted to pumping blood from your system out to your lungs and then back from your lungs into bringing that back into the heart. So blood comes in to the right side of the heart, and then from the system and through the vena cava, and then is pumped out through the pulmonary trunk, and from there goes out to the pulmonary arteries. Now, of course, the pulmonary arteries are a weird exception in terms of arteries in that they're carrying deoxygenated blood. So these blue pulmonary arteries are carrying deoxygenated blood out to the lungs. It passes into, through the arterioles into these capillaries that are right around those alveoli, and then passes back into the pulmonary venules and the pulmonary veins, and then this comes back into the left side of the heart to be pumped out to the rest of the body.
Around the lungs is the pleural cavity. The pleural
cavity
is lined by the pleura. These are a set of membranes. They should look very familiar from the meninges, from the membranes around the heart. This is a pleural sac with 2 layers and a fluid layer in between. Once again, should look very familiar. There's the visceral pleura and the parietal pleura. So these, and in between you have the pleural cavity with fluid. Now this pleural cavity is really important because this is where the negative pressure develops when the diaphragm goes down to pull out the lung to inflate those alveoli.
Now those alveoli are receiving this air, and we have these very specific little sacs. It's coming in, and as long as there is air in there, these alveoli will stay open. Now, when you breathe out, you're never completely emptying those alveoli of air. And we can look at the flow in the alveolus. So one thing that you'll particularly note is that the air kind of hits a dead end in the alveolus. It comes into this little circle and swirls around in here. And at that point, it has to come back out. And what this means is that there's never complete exchange of air between the alveolus and the outside. It doesn't pass through, it goes in and it goes out. So some of it is sort of dead air in there, which means that actually the air in your alveolus is always lower oxygen and higher carbon dioxide than the air that you're actually breathing in.